Hi everybody, this is the video that I promised you that I didn't get to have for you yesterday. We're going to be doing similarity in class on Thursday. You did ratio and proportion related to two ratios making a proportion. We worked in class. Today, or over the weekend before class on Monday, I need you to have a lot of this information settled so that we can be working on this in class starting right away. Alright, so a lot of this stuff is kind of new. It deals with what's called similarity. And we deal with the concept of similar. So if you need to pause this video at any point, please do that so that you can take down any of the notes and write them down. So, and if you need to go back and watch it again, you can do that so you're familiar with the vocabulary and how they work. So, first thing we need to know is what is similar. And two polygons are similar. A polygon is a multi-sided figure. They're similar if and only if their corresponding angles are congruent and corresponding lengths are proportional. Okay, all of those things need to be happening at the same time. And if they are, then we can say that the figures are similar. We just got done with a unit on congruent triangles. And we did all those things, SAS, SSS. And if we had that, then we could say that the triangles were congruent, meaning same size and shape and everything. Similarity, though, is a little different. And here's the example. We've got two figures right here, two polygons. And there are four angles and four sides. And so that the corresponding angles have to be congruent. Okay, so let's talk about that. This is what we have to have happen. Before I keep going, if you need to pause this video and write down this definition, you might want to do that. Make sure you've got that definition in your notes for that. So for angles, corresponding angles would be angle A and angle W here. It's the matching correspondence. And we've dealt with corresponding angles when we did parallel lines with the transversal a couple of months ago. So angle A and angle W are corresponding, and if they are congruent, and if angle B and angle X are congruent, and if angle C and angle Y are congruent, and D and Z. Those are the four corresponding relationships. And if they're all congruent, then we're halfway there. You remember that song, right, Colin? Halfway There, Living on the Prayer. Bon Jovi, one of my favorites. That might be your homework. Listen to it a little bit before Monday, too. So we've dealt with the angle part, okay? Now we have to deal with the sides. And let's go back to the definition. Always go back to the definition if we have a question. So corresponding angles are congruent. And corresponding lengths are proportional. So, AB, segment AB is 15, segment WX is 5. And if we make a ratio of AB 15 to 5, and we did ratios in class the other day, okay? So 15 over 5. BC to XY is 12 over 4. So there's our example there. CD is 21, YZ is 7. So there's that relationship. And then DA is 18 and WZ is 6. So, all four of those side lengths, all four of those segments, are they proportional? 15 to 5 is 3 to 1. If we simplify this ratio, it becomes 3 to 1. 3 to 1, 3 to 1, because this one goes into this 3 times, all the way around, into there 3 times. So the relationship is 3 to 1. And so if we have all the angles, corresponding angles congruent, and the corresponding lengths as being proportional, now we can say that these polygons are similar. They're not congruent because they're not the same size. They're not. The angles are the same, but the size is not the same. This is 15, this is 5, but they're similar. So proportionally, they're the same. And what's the root word of similar? Same. Okay? This is how we write it. We would write it as ABCD is similar. There's the little squiggle that you use. I'm a good vocabulary guy, right? It's called a squiggle. And then WXYZ. So figure ABC is similar to WX, Y, and Z. Okay, so that is the main part of these. The last thing that I want to talk about is this relationship of 3 to 1. Okay, this is what's called the scale factor. Okay, so the relationship between the larger figure and the smaller figure, even though they're similar, the scale is 3 to 1. You guys have maybe experienced this with a map. If you've seen a map of the United States or a map of New Hampshire or a map of the world, there's a little key somewhere on the map that says each line is worth 1,000 miles or something like that. That's the scale. So this is 3 times the size of this, 3 to 1. That is the scale factor. Okay? So, this covers a lot of the things that you are going to be doing in the next section. And it deals with similar polygons. Okay? Are the polygons similar? So you're going to be trying to identify these. It's a lot like what we just did with congruent triangles. So, please make sure that you have these notes down ready to go, because on Monday's class, we're starting work right away. Okay, and we need to be able to get a lot done in class. Remember, I did that little calendar with you. We only have about 7 more classes left to get through a lot of stuff. Okay, so go back, watch it again, get your notes down, and be ready to go and use this information for Monday's class.